Section 6, Model and Strategy Evaluation. We start in the first video lecture introducing value at risk backtest by introducing the basics of risk management. The function of risk management is as important as the signals of the financial indicators driving the traits and the positions we are assuming during the simulations are in the real-time trading, which ensures profitability. So let's introduce the basics of risk management together in the next slide. One of the items of the standard is the process of risk management itself. We start by defining the goals and the objectives of the financial organization. Once we have a crystallized clear idea of the objectives and the goals, then we define the metrics by which we are going to measure the risk associated with these goals and with different strategies. Finally, at the end of the process, we need to design a system that detects anomalies from the measurements we have set and the goals we have aimed at. So a financial manager or investment manager should start by asking himself a few questions. So first, he needs to define the sources of risk, whether they are coming from the market, from legal, from volatility, and so on. And then they should set acceptable risk-reward ratios. What is the amount of risk taken and what is the reward can be returned from such a risk. Having done that, we can minimize the risk-reward ratio and we ask what is the minimum risk-reward ratio we are willing to take. Finally, he should answer the question of what actions should be taken in case of breaches of such ratios that were set either as minimum and acceptable. So, if the price or the loss goes below the minimum risk-reward ratio allowed, what should be done? Risk, however, is categorized according to the Basel Committee of Banking to different categories, and each requires a specific risk measurement procedure. On the screen right now we can see there are 5 different risk types: the market, credit, liquidity, operational, and legal risk. As data scientists or programmers, we are more interested in the market risk since they have a very direct effect on the programs we are writing. The remaining types of risk are more of the job of a financial analyst. There are also different kinds of risk measurement techniques that has evolved. Each one of them addresses a different problem and has its own pros and cons. We should be very familiar by now with the statistical models, as we have seen them together in many applications based on the work we have done in the previous sections. We introduced the final step in the process of risk management, which is the action plan. So what should you do when the limits or the boundaries of your strategies have been breached? One of the things that we have introduced in the previous section is the stop loss, which is that you exit all the trading positions whenever the price dives down below a certain level. Another alternative which can be taken when the price levels has fallen is to use hedge funds. This way, when you borrow money from investors or from the brokers or from anywhere else, then you are distributing the losses associated with your trading strategy among the partners. So value at risk, or in short VAR, is a statistical modeling for risk measurement and it is preferred whenever possible. Another terminology that is associated with the VAR is the ES, or the expected shortfall, which is abbreviated as ES. This is another pillar in order to calculate the VAR and apply the VAR analysis for the backtesting. The expected shortfall is the average of the VAR. So the mean, mu, and the standard deviation sigma, they are statistical properties of the Gaussian normal distribution plotted on the screen right now. You can see the Gaussian distribution takes the shape of a mountain that's very high in the middle and then very small at the tails on either side, one in the positive direction and one in the negative direction. So we are interested in the left direction, the direction of loss, and here we set alpha to be the percentile that we are interested in to calculate the value at risk within. This is however named parametric VAR, since we have made an assumption about the underlying distribution of the returns, which is that it is a Gaussian normal distribution.